Hello to Dr. Rozaimi and everyone. My name is Balkis and I will present about elastomers, structures and properties. Focus on understanding the basic of elastic polymers. This is the overview that I will go through one by one, which are what is elastomer, the structure, type of elastomers, the properties, examples and applications. This slide I will explain what is elastomer, one kind of polymer. Polymer is a chain of linked molecules created by a chemical process. Both plastics and elastomers are types of polymers. Polymers with elastic properties are called elastomer. Elastomer is a polymer with the property of elasticity, deforms under stress and returns to its original shape, generally having low Young's modulus and high yield strain, as we can see from this graph. The structure of elastomer. The general molecular form has been linked to a spaghetti and meatball structure, where the meatballs signify cross-links between the flexible polymer chains, which are like spaghetti strands. Elastomer is made up of repeated single monomer or two or more different monomers made up of carbon, hydrogen, and oxygen atoms, and occasionally silicon atoms. Elastomers can be divided into three types of materials, which are: first, thermoplastic elastomers. Thermoplastic elastomers are elastomers that melt when heated because their crosslinks are significantly weaker, allowing the material to melt and reform without losing its elastomeric properties at operating temperature. These elastomers are generally easier to use in manufacturing because it can be molded, extruded, and reused. Example is injection molding. Also, it exhibits a greater ability to stretch compared to thermoset elastomers. Second is thermoset elastomers are elastomeric materials that do not melt when heated. These are the most common type of elastomers. Thermoset elastomers usually require vulcanization, which is a chemical curing process that forms crosslinks in a polymer chain to increase rigidity and durability of rubber products. And last is natural and synthetic elastomers. Also, we call natural rubber and synthetic rubber. Natural rubbers come from biological sources, mainly plants, while synthetic rubbers are chemically synthesized from petroleum products. Natural rubber often requires processes like vulcanization to enhance its properties, whereas synthetic rubbers can be formulated to exhibit desired characteristics without extensive additional treatment. Next is properties of elastomer. One is high elasticity. Elastomers tend to exhibit a high level of elasticity, making them more resistant to breaking or cracking. As we can see from the stress strain graph, here is the yield point or the elastic limit. If we can compare all the limit points, metal is here, plastic is here, then elastomers is here, more yield point compared to metals and plastics. In fact, elastomers can reversibly extend up to 700%, depending on the specific material compared to metal, which is only 2%. The cross linkage between the chains ensure that the elastomer returns to its original configuration when the stress is removed. A simple example is a rubber band. If you stretch a rubber band, it snaps back to its original form. Other properties is high resilience. High resilience is the ability to return quickly to their original shape after temporary deflection. In other words, it indicates the speed of recovery. This property is essential for applications where energy return and durability are crucial, such as tires, seals, and vibration dampers. And other properties of elastomers are low permeability to air, gases, water and steam, good electrical and thermal insulation, good mechanical properties, the ability to adhere to various fibers, metals, and rigid plastics. Because of their unique properties, elastomers are used in huge range of industries in a variety of applications. The following are just a few types of elastomers and how they are used in various industries. First is natural rubber, consisting of the organic compound isoprene derived from the rubber plant. Natural rubber is highly elastic and strong, but is susceptible to aging and swelling in the presence of oil, making it less ideal in the production of seals. Natural rubber is most commonly used to produce automotive products, wearable items like footwear, and rubberized fabric, latex products, and anti-vibration materials. Second is polyurethanes. Polyurethanes are extremely versatile in manufacturing, able to provide tough, reliable results. Generally, polyurethanes are used extensively in textile industry to produce elastic clothing like spandex. However, the thermoplastic polyurethanes are also used to manufacture shoes, cushions, cables, seals, and technical parts. Next is polybutadiene. In combination with other rubbers like natural rubber or citrine, polybutadiene is an essential elastomer, especially in the production of automotive tires. Next is neoprene. This synthetic rubber is highly resistant to degradation and is very well suited in the production of corrosion-resistant gaskets, hoses, and coatings. Most famously, however, neoprene is used in wetsuits. These are few applications of elastomers in industries. First, in automotive, we have tires. Tires are made with a variety of synthetic and natural elastomeric materials, which help give them excellent flexibility and durability on the road. In industrial, we have conveyor belts, and belt parts are commonly made of elastomers for their ability to resist deformation over long periods of applied stress. And in medical, we have gloves. Latex is made of natural rubber, and these gloves are extremely common in the medical field, able to provide a barrier between caregiver and patient to maintain sterile conditions. Non-latex gloves are also made of elastomeric materials. Other application, we have footwear. Elastomers are extensively used in footwear applications. Polyurethanes and natural rubbers allow for excellent flexibility, allowing footwear to move with the wearer while also cushioning the feet and joints from impact. Additionally, some elastomers can be manipulated more freely, allowing for greater design freedom for footwear companies to keep up with current trends. And these are references I took for making this topic of elastomers. That's all. Thank you for listening.